All right, there's actually a second part to this problem, and it says what would be the limiting value of this current? Or in other words, what is the value of I of t as t approaches infinity? This is just a limit problem. What's the limit of I of t as t approaches infinity? So it's asking me to take the limit as t approaches infinity of 5 minus 5e to the negative 3t power. And this may seem a little bit scary, but it's really not that bad. Think about as t gets bigger and bigger and bigger. As t approaches infinity, this exponent is going to approach negative infinity. Negative 3 times infinity is negative infinity. So what you're thinking, what this really is 5 minus 5e to the negative infinity power, which another way to think about this is 5 minus 5 over e to the infinity. Bring it down, that e to the negative infinity down to the bottom. And now the bottom of this fraction is getting bigger and bigger and bigger. So 5 divided by a huge number is going to approach 0. So 5 minus 0 is 5. Another way I like to think about it from the beginning is rewrite it as limit as t approaches infinity of 5 minus 5 over e to the 3t. And then from there, I think it's pretty easy to notice that, well, the bottom of this fraction is going to get bigger and bigger and bigger, infinitely bigger. So 5 divided by a huge number approaches 0. So that limit is 5. All right, last problem. Solve the differential equation e to the negative y times y prime minus x equals 1 for y equals f of x. So once again, we see this y prime right here. I would suggest rewriting the y prime as dy dx. All right, so all of the y's on one side and everything that has to do with an x on the other side. So the first thing we'll have to do is add x to both sides. So we have e to the negative y dy dx equals x plus 1. And now all we have to do is multiply both sides by dx. So e to the negative y dy equals the quantity x plus 1 times dx. And now I can integrate both sides. All right, the integral of e to the negative y dy is negative e to the negative y. You could do a u substitution, letting u equal negative y. Or remember how we talked in class that the integral of e to any number times x is 1 over that number times e to the ax plus c. So the integral of e to the 5x is 1/5 e to the 5x. So when you integrate e to a number times x, it's what you're starting with times the reciprocal of that coefficient right there. All right, when I integrate the right side, I get 1/2 x squared plus x plus c. Don't forget your plus c. Okay, to solve for y, when your variable is an exponent, we can take the natural log of both sides. But before we take the natural log, please, please, please multiply both sides by a negative 1. We want to start with, when we take the natural log of both sides, we want to just have e to a power. So when I multiply both sides by negative 1, I get negative 1/2 x squared minus x. And negative 1 times a constant is still a constant. So I can still put plus c. And now I can take the natural log of both sides. But just make sure that on that right side you take the natural log of that whole quantity. And the natural log of e to the negative y power is just negative y. And then equals the natural log of negative 1/2 x squared minus x plus c. And then all you have to do is multiply both sides by a negative 1 to get y by itself. So y equals the negative natural log of 1/2 x squared minus x plus c. Oops, sorry about that. This should be y equals negative natural log of negative 1/2 x squared minus x plus c.